All right. Hi everyone, and welcome to another edition of our project Spotlight. And today we'll be, you know, talking about um, TX5. So we have the honor and privilege, having Santiago, who's from TX5 with us into this call. So I guess I'll have to leave it for him to introduce himself. So Santiago.
Yes, thank you guys for having me. I'm Santi from the TX5 team. At TX5, we build open source tooling for blockchain, particularly in the Cardano ecosystem. We've been around for quite some time now, several years, and we've been working mainly on infrastructure components, things like data nodes or data pipelines or RPCs and APIs. And lately, we've been very focused on a tool that we call Tx3, and hopefully we can talk a little bit about that one.
Absolutely. Yeah, for sure. Yeah, I would also go ahead and introduce myself. So hi, my name is Uche. I'm a developer advocate here at Intersect. I work basically within the Intersect open source office, and my goal is to help build this community, amazing community of developers within the Cardano ecosystem. Yeah, wonderful. I guess we'll just dive right into, talking a little bit about TX3. You know, um, so what's the vision behind TX3? What problem are you trying to solve? Just can you kind of share a little bit about TX3?
Yeah, sure. So I think it's no secret that developer experience in Cardano it's kind of tough. I think that it's a mixture of several things, but from my perspective, the main concern is more on the UTXO side than on the Cardano side. I think that the industry has developed best practices and abstractions and tooling for the account model much more than for the UTXO model. And the reason why I think it's because for starters, it's a little bit more complex to model actions and interactions and applications on top of UTXOs. The account model is much more straightforward in that sense. But also because when we started building things, and I believe that the Cardano ecosystem is probably the most advanced community in terms of trying to extract all of the potential out of the UTXO model. But I think that we tackle the problem at a very low level. I think that the abstractions that we are using when we try to model applications are too low level. Because if you're a developer in Cardano, you probably know about on-chain validators, and that's what we share. We share that an application has this set of validators, and these validators have this specific shape, but there's nothing from the level of a transaction because applications and developers probably think about interactions in terms of user intents. So, for example, let's say that you have a decentralized exchange. Right now, when you model an application like that, you have to think about different validators and all of the criteria that they have to check and ensure. But when you're trying to build the app, you should be probably talking about the intents of the user against that protocol. So you should be thinking in terms of, I want to make a swap, or I want to add liquidity to a pool. Those are high-level actions, user intents, but there's nothing at the validator level that describes those intents, because that abstraction is most likely represented at the transaction level. But there's nothing, there's no mechanism, there's no tooling to describe the interface of your applications at the transaction level abstraction.
Mm. Okay.
Because for validators, we have, not sure if you're familiar with the Plurus.json format, which is a way of describing the interface of your validators, but those are just very low-level primitives. There's no Plurus.json that describes how the transactions should look like, because those are the ones that describe the high-level user intents.
Mm.
So with that in mind, I believe that if we could have a language that presents a UTXO protocol from that high level of abstraction, everything will be simpler. UI will be simpler because they can just infer what the user intents are from looking at the transaction abstraction. The transaction building logic will also be simplified, because if you have a definition of what the transaction should look like, you can probably auto-generate the code behind the transaction building.
Mm.
And also building the validators will probably be also simplified, because now if you start from the transaction level, you can scaffold the structure of those validators and leave just the developer to fill in the gaps of the very narrow and specific validation criteria inside the validators. So instead of starting from the bottom up, as we tend to do in the Cardano ecosystem, the proposal of Tx3 is providing you with a language that allows you to describe the interface of your UTXO protocol from this higher level abstraction, and then all of the other components will just kind of build on top of that common definition. A good way of comparing this to something in the Web2 world is to think about Tx3 as sort of an open API spec. If you're familiar with APIs, you will probably have seen a Swagger file, which is just a way of describing the interface in some JSON format. Well, Tx3 is kind of like an analogy of that, but for describing UTXO protocols.
Oh, wonderful. Yeah, yeah. I mean, that was exactly what came to mind when you were describing, like, the interface and all of that. So yeah, very spot on. Yeah, so we'll kind of like go a little bit into the details of, like, the TX3 model. So can you kind of like walk us through the core components of a TX3 protocol definition? Like things like parties, transaction templates, inputs, outputs, datums, things like that.
Yeah. So the best way to think about it is to maybe compare it to a transaction builder, because you will have the same kind of artifacts inside of it. You start from a TX3 file, and inside that file, you will be writing your interface in terms of transactions that can be executed against your protocol. So if you're building a DEX, for example, your TX3 file will look like functions that describe those intents: add liquidity, make a swap, and so forth. Within each of those functions, which are called transactions for obvious reasons within the context of TX3, what you will need to describe is what inputs do you have, and which outputs do you have, and which constraints do you have. But everything is parameterized in terms of arguments that you can pass when you invoke the transaction. So now, instead of having just a description of the shape of the transaction, what you end up having is a description of how to generate transactions from specific parameters. So continuing with the example of the DEX, if you had this add liquidity transaction inside the TX3 file, you will probably have the amount of liquidity that you want to add as one of those parameters. So that's the definition of your protocol. I'll stop there in case you have any questions, but from that definition is that then you can infer a lot of other things, which is where the actual developer experience benefits happen.
Yeah. Wow. That's wonderful. So basically, like, I'm curious, I mean, you talked about TX3 kind of like introducing the idea of describing dApps, as UTXO protocol rather than application. But like, I'm curious, like, what's the conceptual shift that is required from developers, right? Because this is completely different from what developers are used to. Um, I don't know if you
So uh,
question.
yeah, I think that the main mind switch that developers have to apply to use TX3 is that instead of starting from the bottom up, meaning from your validators on chain,
Mhm,
you start from the higher level abstraction, which are the transactions. So you first define which are your using intents,
mhm.
make a swap, a liquidity, and then you start to dig in deeper into each of those components. So it's more about switching the entry point for the development instead of starting from the validators and then building the transaction builder stuff. You start from defining your transaction and then you fill in the gaps of the smaller components.
Yeah. Yeah, and personally, I think I like, this new way of, like, this way of doing it, right? Because it kind of like allows the developer to think deeply about, what they want to actually build, right? Instead of like starting from the bottom approach where you kind of like just, do things along the way. So I think,
Yeah, exactly.
yeah, this is,
Uh, yeah, and I think that it's uh, probably the validators end up being the artifact that you need to take most time on, and the one that you need to really think carefully about how you implement it. That doesn't change because what happens on chain is your final firewall, right? The validator will be what defines if you get hacked or not. So you need to pay attention to that for sure. But I think that if you start from the top, it's a much more streamlined
yes.
mechanism for development. And hopefully we can talk a little bit about each of the specific features. But from having that definition of transactions, there is a lot of the boilerplate stuff that developers have to do that can be automated thanks to having a very strict definition of what the protocol looks like from the outside.
Yeah, absolutely. Yeah, I mean, you talked, you kind of like highlighted a little bit about, some of the features, and I would like us to kind of like touch on it a little bit, the tooling and what the workflow looks like. So I'm curious, like, what does a typical developer workflow look like when using TX3 toolchain? So what tools or technologies that the developer needs to know, to be able to kind of like move from start to finish, when using
Yeah.
TXT.
Yeah, great question. So I would recommend checking out the TX3 docs. There's a quick start guide of how to install the toolchain.
Mm,
So you start from installing the stuff that you need, and that will give you a CLI, a command line interface that it's called Trix, Trix, which is like the project manager, the package manager for TX3 projects. It's like the NPM
mm,
to JavaScript. So
yeah,
with tricks is where you probably start doing anything TX3 related. There is an init command, so tricks init, that will ask you a few questions about the context of your project, and that will generate a little bit of the initial scaffold of the project. That means a configuration file, the main TX3 file where you start adding your TX3 code, and a few other artifacts for testing and metadata. So that's your entry point. But from that point forward, you need to start describing your protocol inside the TX3 file that you have in there. And for that, you can use your IDE of choice. You can use VS Code or Cursor or whatever you like. And there are plugins, extensions for those IDEs specific for TX3 that give you a lot of the syntax highlighting and static analyzer and error notifications and all of the nice things that we like about a language. So there is actually a compiler that gets installed with all of the other binaries that will be, every time you edit or compile your tx3 file, it will be turning that tx3 file into a lower level artifact that describes, um, it's what we call the transaction intermediate representation. So it's like a compact version of what the tx3 file is describing. That is actually what then gets executed, and I can get into that because the runtime mechanism is important in all of this mix. But from the development side, what you have is tricks as an CLI entry point. You edit your tx3 file with your IDE of choice, and when you're ready, you can run tricks build, and that will give you the I don't want to call them executable artifacts, but they are sort of that. They give you the artifact that you can use to actually build transactions by passing arguments.
Mm.
There is one, and maybe I can get into that a little bit, because once you have this kind of compact version of what your protocol looks like, you need a way to execute. You need a way to get the actual seaward transaction.
Yes.
So that means with your tx3 compact representation plus a set of arguments, let's say, I don't know, I have my DEX protocol and I want to execute the swap transaction. So I need to pass the token that I want to swap, for which other token I want to pass, and the amount. So I need to pass those arguments in order to get a concrete seaward transaction that I can submit into the chain. So how do you execute that? How do you obtain that concrete transaction? You need a way to resolve the tx3 artifact into the final seaward shape. And for that, there are several options. There is one that it's called code chain, meaning that you can turn that tx3 artifact into an executable in the language that you prefer. So you can run tricks code chain, and depending on the choices that you have on your configuration, that will generate Rust code or TypeScript code or Python code or Go code that gives you a function in your language, meaning that you will have a function in TypeScript that says make swap, and it will let you pass the arguments directly, and that function will return you the zero transaction. So in other similar contexts, I was mentioning Web 2 and APIs.
Yes.
There's a similar workflow where you have your Swagger or your Open API spec, and you code chain your server and your clients. That means that the compiler will speed out code in your language of choice. The same happens in Tx3. When you put tricks code chain, the toolchain will interpret the Tx3 and give you Python code, TypeScript code, ready with functions to execute your transactions.
Awesome. Awesome. So all of this comes with the toolchain, right? It comes with you, installing tricks in your system, right? Absolutely.
Yeah, and there are other nice things that come with a toolchain, which maybe are not specific to Tx3, but I think they are very nice to have things in the developer experience toolkit for a UTXO developer, for a Cardano developer. Because, for example, you can run Tricks DevNet, and that will start a local node, very lightweight node. It's like an emulator of a Cardano node. Actually, behind the scenes, it's using another TX5 tool that it's called Dolos, which is a lightweight node just for this type of purposes. So it means that without having to install anything extra, you get a way to submit transactions, test those transactions, and see how it changes on the ledger, and you can see from a wallet what the balances are, and you can execute Plurus validators, and you run the transactions as if they were almost real because they are running in a emulated context. but all of the same validations, all of the same rules apply. So you have
Mm.
a very tight developer feedback loop where you edit the TX3, you compile it, and then you test it right away in the DevNet that you have running side by side locally in your own machine. When you're ready to deploy that into some sort of, I don't know, a backend server or maybe a front end, web front end, what you do is you code gen and you get your TypeScript library, you get your Go library, and you deploy that to the backend or the website.
Yeah, interesting. So that also leads me to the next question, right? Because when we talk about like tools like this, you also need to consider like integration, right, with existing Cardano tools. So like since TX3 is kind of like designed to complement existing smart contract languages rather than replace them, how does it integrate with other tools? How does that integration work? Tools like ICANN, for example.
Yeah, so I mentioned that you can scaffold the contract. So there are two ways, because we have a lot of momentum of teams building validators, and they start from the validator side. So you will see a lot of existing teams that they have their validators and they have their Plutus.json file. So we wanted to support both approaches, those teams that already have things and how they can build that TX3 layer on top. But we also want to support a top-down approach, which is what we believe the most streamlined approach, where you start from your transaction definition, and the toolchain will scaffold the structure of your on-chain code,
Mhm.
leaving in the gaps for you to fill with the rest of the validation. So if you're starting from the top and working your way down, there is a scaffold command. That means that you define your transaction, and then you run scaffold on chain, and that will generate the validators in ICANN language, and that's the one that we support right now, but without any internal business logic inside the validators. It will be like setting up the skeleton of all your validator code that already connects and will be imported by the TX3 file whenever you compile it. But it
Mm,
won't be doing nothing. It will be a always pass kind of validator.
mm,
Now, that leaves the developer the task of, once it has that icon code, to go in there and update whatever validation rules they need to apply.
yeah.
Now, if you go on the other side, uh, what you can do is from the TX3 files, import Plutus.json files. That means that the toolchain will interpret what is inside the blueprint file, the Plutus.json file, and it will create the same artifacts and the same types and the same validator entry points, so that you can call them and use them within the context of your TXT file. Because the idea here is that you shouldn't be duplicating artifacts in both places. If you define a type for your datum inside ICANN and you have it available on your Plutus.json, you should be able to use it without having to re-implement it on TX3. And the other way applies too. If you start from TX3, you can define your datum types inside the protocol definition inside the TX3 file. And whenever you scaffold the ICANN code, that will get also added directly to your scaffold content.
Awesome. Wonderful. I mean, as we were kind of like having this conversation, you know, I kind of like, yeah, we've talked about like the workflow, we've talked about like, how you could integrate. But I think the part that we didn't really like touch on is like testing, right? So like how does TX3 fit into that whole entire stack? How does the testing happen in this case? Because I mean, you would agree with me that in building, transactions, or rather in performing transactions like this in prod, you need to kind of like have, you know, uh, you need to have to test these things, before pushing to prod. So like, how does TX3 kind of like fit into that entire stack?
Yeah, testing has been always one of the big pain points, in my opinion, in the ecosystem. And we have this tendency of going directly to some of the test nets for our initial attempts of trying out a protocol, or at least that's what I've seen from many teams. And I think it's obviously a great resource to go to preview or pre-prod test nets in order to try out your protocol, but there should be a preliminary step, which is what I was describing with this local mechanism for testing as you code. Because, and I believe this applies for any kind of development workflow, any kind of language, blockchain or otherwise. If the development feedback loop is too long, meaning that from the point where you change something to the point where the developer can assess if that change was valid, if that feedback loop is too long, the developer experience will just suck. Uh, if you manage to tighten that feedback loop as much as possible, that's when development gets more productive. And also in the age of coding agents with AI, having a way to automate the feedback loop, it's also interesting because it allows the agent to kind of get its own feedback and continue developing. So we can go into the whole how AI fits into this model, but in the traditional sense, any feedback loop that it's too long, it will just add a penalty to the whole development workflow. If you manage to tighten that up, it will be probably best for the developer and the overall throughput in production. Now, the way that you do that most of the time is with some sort of local testing artifacts. In the TX3 world, what we have is this devnet command. Um, that means that you will get like a mini Cardano node running directly in your computer, and you don't need to worry because it doesn't consume much resources. It's a very trimmed down version. So with just a few megabytes of RAM and very little CPU, you will get something that is just producing empty blocks. And whenever you submit something, you will just apply it to the next block. But all of the phase one validations of a transaction, meaning conservation of values, that certificates are valid, that UTXOs exist, all of those phase one validation concerns will be executed and you will get feedback if you are doing something wrong. But also the phase two validations, which means all of the execution of the Pluto scripts, those will also happen in this DevNet environment. So you can get feedback directly from what you're submitting without needing any other external dependency. This doesn't connect to a server. This doesn't need a very huge database of blocks. This is just a very lightweight process that runs in the background, and you can use it for testing. The
Awesome.
other thing that the toolchain gives you as a nice to have is this idea of defining personas, like known parties within your protocol. And that is a first-class citizen in the TX3 language. When you define your protocol, you start by defining which are your parties, like the actors that will be participating in your protocol. When you use the toolchain for testing, it will automatically generate test wallets for each of these parties. And these wallets are generated in a deterministic way, so they will remain constant across time. And that allows you to start adding sort of integration tests, which means that you can describe transactions in the sequence that they need to happen in your protocol. For example, the user adds liquidity to a pool, and then user B another party makes a swap, and then user A gets its rewards, and you define that sequence of actions that describe how you foresee the users using your protocol,
mm,
and then you put that into a test file, and the system will generate internal test wallets for each of the parties, and it will start executing the sequence of all of those transactions against your local devnet. And by the end of the process, you get um, a chance to assert like in testing, when you assert that two things or things have a specific shape or constraint, you
mm,
can assert the balances of the wallets of those actors that you define in your protocol. So you can say, okay, after all of this user journey where all of this transaction happens, this user needs to have this token in its wallet and this amount of lablets in its wallet. If that didn't happen, it's because the test failed. So you get this very direct and quick feedback right out of the box.
awesome. Awesome. Yeah, so let's, talk a little bit about like visualization and, protocol design. Um, I know in TX3, you know, there is like three levels of visualization for protocols. There is the interaction level, there is the transaction level, and there is also like the validator level. So how do these diagrams help developers reason or think about complex UTXO systems?
Uh,
Also
yeah,
curious, like how did that idea of adding those visualizations come about?
yeah. Uh, Actually, the trigger for the whole TX3 idea was that in TX5 we perform a lot of audits of validation on-chain code. And one of the artifacts that we usually generate as part of the audit process is this transaction diagrams, which you've probably seen many times. It's the box with each of the inputs and also arrows describing the outputs. And then maybe you can connect multiple transactions, and this input goes into that transaction, but then the output goes into that other transaction. So, and then you sometimes in those diagrams, depending on the level of detail, you can also describe what type of assets and tokens do you should be in a specific output, and you define also parties that are involved in those inputs and outputs. So that's a common way of describing and visualizing transactions in a way that we can rapidly interpret and without much effort. So it's a great mechanism for understanding protocols. So we wanted to have a way of not having to manually create these diagrams.
Yeah.
So it made sense to have some sort of DSL, some sort of domain specific language to describe what those diagrams, the content of those diagrams, sort of like Plant UML or Mermaid, if you're familiar with it. Those are DSLs for generating diagrams. So we thought, okay, let's have some sort of DSL for describing transactions. Now, the end result was that we discovered that by having a DSL that describes the transaction, you can then simplify a lot of the rest of the development workflow. So that's how it came to be. And the we also understood that the level of detail depends on that you have a lot of different detail that you might want to show in those diagrams. So if you want to put all of those details in a single place, it just becomes a mess and it's too complicated to understand. If you remove all of those details, sometimes you get with something that gives you an overview, but it doesn't go into the actual description of the protocol. So we decided that one single detail level wasn't enough.
Mm.
So that's where the three comes from Tx3. We decided that we have three levels of detail when you describe a protocol. One is the context, the more zoomed out level describes the context. That means that will show you which parties are involved, like a lender and borrower, for example, and also describe the transactions in terms of names of borrow or lend, and it will give you a very broad perspective of which party uses which transactions and what are all of the transactions available in a protocol. If you zoom in one level deeper,
Mhm.
you what you get is a single transaction with each of the inputs and outputs that are involved with that transaction, and it gives you a hint of which assets, which policies, and which amounts and which parameters for the transaction are linked to each of those inputs and outputs, and to which parties those inputs and outputs are directed. And there's also some details of, for example, things that get minted or burned, or certificates that you have inside the transaction. But it's like uh, a very well-rounded description of a single transaction.
Mm.
If you go one level deeper, that's where you get into the level of describing data structures and constraints, and that will show you, for example, the structures of your datums and your redeemers, and where you link to the on-chain code. So that's the deeper, most detailed level where you start to see more of the internals of how the protocol is implemented, and that
Yeah.
is why you have three levels.
Yeah. Amazing. I mean, this kind of like shows me that this entire two chain and workflow was built with a lot of love for developers, and it kind of like this is like a pure example of a good developer experience, right? Because it means that while you're building this different tool chains and different workflows, you had like developers in mind. But I'm also curious, like, do you see this visualization tool becoming part of the standard workflow for designing protocols in Cardano, for example?
Hopefully, yes. I think that will be up to the community. What I think it's a really interesting use case of having a way to describe the protocols, and not only from the visualization side, but from the perspective of the interface, is that I believe it lowers the entry barrier for a different type of developers that are more about the use case, are more about integrating things that already exist on chain, rather than the protocol authors that we are used to see in the community and in the ecosystem. Because right now, if you talk to any team, probably that team started from defining their validators and their UTXO protocol, and then they build some sort of backend or some sort of front end, and they connect it to the wallet. So they have like the full stack that is specific to DEX, that it's specific to a lending protocol. Everything from the user, the UI, and the user experience, down to the on-chain validator that gets executed. And
Mm.
to be honest, I think that the future should look a little bit different, in the sense that protocols, meaning the things that interface with the on-chain validators, should be
Mhm.
more like APIs,
Mm.
and that the application layer shouldn't be directly linked or owned by a specific team that has handled the protocol. I think there is a lot of interesting use cases where you start composing different protocols against each other, or um, interesting use cases where you maybe take a protocol that already exists and you integrate it with some workflow that exists in some other context, maybe not specifically related to the DEX or the team that created the protocol. And in that way, you get a much richer ecosystem where people are just cross-pollinating transactions from different places. Maybe some application, some app in your phone needs to borrow or needs to mint some stable coin in order to pay for something, instead of having to go mint inside of the stable coin. You just execute the transaction because you know how to interface with that stablecoin protocol. And in that way, the mobile app in your phone, without having to go through a lot of steps, it just exchanges the or mints whatever stablecoin you need, and then it uses it in a specific purchase. I don't know. But besides a concrete example, the point is, if we could turn all of the on-chain protocols that we have into APIs that anybody could use, I think that would be better. Would be awesome for everybody, because protocol authors will get more transactions, hopefully, and also application developers now have a lot of things that they can, out of the box, integrate with their own workflows.
Yeah.
But in order to support that, interacting with a protocol shouldn't require a lot of effort understanding how to build the transactions, or knowing specific dependencies for that transaction builder. Maybe some protocol has a transaction builder, but it's using, I don't know, maybe Mesh SDK, and another one is using Scalus, and another one is using Lucid. But the application layer that wants to interact with one of these protocols now has to somehow adjust to the existing libraries, or it has to build its own. If
Awesome.
we have a common place where you have the description at the interface level of these protocols, and you can auto-generate the code for the transaction building step, my belief is that you will start to see new use cases where people that are not the protocol authors now have a very low entry barrier for integrating these protocols into their own workflows.
Awesome. Yeah, I completely agree with all you've said. I wanted to, before we kind of like wrap up, I wanted to touch a little bit on security, because it is critical. So when designing protocols using Tx3, like how do you approach security in things like, let's say, like transaction templates? How does that whole thing
Yeah,
work?
so the last line of defense is the on-chain validator. So as I mentioned earlier, starting from the top doesn't mean that you will have less effort on making sure that your validator is robust and resilient and secure. So that doesn't change. Now, what you get as an extra, which helps somehow with the whole process from the Tx3 side, is that when you're building the transaction, there is already a lot of checks of consistency and value conservation, and just components that are analyzed at the Tx3 level that will stop you from reaching an inconsistent state. So, for example, when you are building your transaction in Tx3, upfront, the static analyzer, meaning that the IDE, your PS Code, will start showing some warning or error if, for example, your inputs and your outputs don't match, meaning that there's no conservation of value. And the it will also start flashing if, for example, the datum that you're trying to put into a specific output, or if the redeemer that you're trying to use with one of your inputs, it doesn't match what the protocol is saying. The static analyzer, before reaching anything on chain, will already start showing you some messages, giving you hints that here there is something that doesn't match. So what you get from starting at the transaction level is that you get a lot of very early detection of consistency that you wouldn't have if you go directly to the validator and the low-level data structures. So that's one thing. But it doesn't mean that you can skip steps in the side of making sure that your on-chain code is as secure as possible.
Awesome. Awesome. Yeah, I think would go to the final part, which is what do you have? What features should we look out for in your upcoming release? Any improvements? Any what should the community expect? From the Tx3 ecosystem.
Yeah. So we have two things that we're really excited about. One is, and talking about security, it's a command inside Trix that is called Trix Audit, and that will, through the use of AI and LLMs, and a set of skills that describe vulnerabilities that, as an audit team, we have identified in our experience. It will give you an automated report of vulnerabilities of your code. That means that, let's say, I think we are about 30 vulnerabilities in our current database, which are defined as files that the LLM will try to identify within your code base and give you some pretty report at the end that says, okay, in your code base, we found this and that. And that will not be green light saying, okay, if it doesn't find anything, you can just go on chain. It's not that, but it will be a very interesting first step before getting a full audit that will let you be much more ready for when you get to be on mainnet. So that's one thing, that automatic preliminary vulnerability reports. And the other thing is dashboards for your protocol. There's a lot of times where you just deploy your protocol and you need some sort of metrics of transactions that are getting through your protocol. I don't know, a log of all of the datums and redeemers that were used in your transactions, the fees and the execution units that were consumed by each of your calls, the set of wallets that have been interacting with your protocol, with some stats and metrics across time. And that is something that we've seen now and again as an interesting requirement for developers. So what we want to do is, with all of the information that Tx3 already provides in the interface, we can start automating the generation of those dashboards. So with just one command, you will magically get a very ad hoc. It's not like an explorer. It's actually a dashboard for your application that is designed and generated specifically for your type of transactions, and you will get all of those nice metrics shown in there. So dashboards and automated vulnerability reports.
Awesome. Personally, for me, I think I'm a lot more excited about the dashboards because it's like, having that central place where you can, see everything. It's gonna be transformational.
It's like when you deploy something to, I don't know, Vercel, like a website or Cloudflare, and you suddenly get all of those nice metrics and reports that show you what activity your protocol is having. It's kind of like that, and yes, I agree. I'm also really excited about that one.
Awesome. Yeah. So before we go, how can developers, start contributing to the Tx3 ecosystem today?
Yeah, everything is open source. You can go to our txpipe.io website, and you'll get links to documentation and the repos. If you want to skip that and go directly to GitHub, you can go to an org that is called tx3-lang, and that's where you will get all of the stuff. And everything is open, and contributions are very welcome.
Amazing. Amazing. If our viewers or our community members wants to find you, where can they find you?
Yeah, on X, my handle is Santi Carmoega, which is like my nickname and then my last name.
Awesome. Beautiful. Santiago, thank you so much for making out the time to talk to us. This was really, really insightful. I personally, I got to learn a ton, and I know for sure our community members would also learn so much from this conversation. So guys, we've come to the end of today's spotlight. Thank you all for joining, and yeah, we'll see you for sure next time. Thank you. Bye.